If you had a board pin such as this, in fact two of them, one straight up and the other turned upside down, and you press them respectively with your left and right thumb with a force of 10 Newton each, what would happen? Well, the answer is that both the pins would press back with an equal and opposite force of 10 Newton, and yet you would feel more pain in your left thumb. In fact, it could probably be bleeding. What is happening here? In the case of the right pin, the force acts over a larger area, that is, the head of the pin. Whereas in the case of the left pin, the force acts over a very small area, that is, the pointed tip of the pin. We say that the left pin exerts more pressure upon your left thumb. So what is pressure? Pressure is defined as force per unit area. In fact, it is defined as thrust per unit area, and thrust is nothing but a force that acts perpendicular to a surface. The weight of a book acting upon the top of a table surface is an example of thrust. Therefore, we can calculate the pressure by using the formula pressure equals to thrust upon area. The SI unit of pressure is Pascal, and 1 Pascal is defined as the pressure created when a perpendicular force of 1 Newton acts over an area of 1 meter square. In general, we can determine the pressure exerted by any substance using the formula P equals to F upon A, whether the substance is a solid, a liquid, or even a gas. To understand the nature of pressure exerted by liquids, we may take a plastic bottle filled with water and prick holes on the walls of the bottle. We would find that the water from the bottle ejects out even from the walls. This means that liquids exert pressure in all directions. This is because the molecules of a liquid are in random motion and therefore exert a force upon the walls of the container as well. So how do we calculate the pressure exerted by liquids? Let's say we have a container that is filled with a liquid of density rho, the Greek letter rho, till a height h above the base of the container. To calculate the pressure exerted by the liquid upon the container whose cross-sectional area is A, we will use the formula P equals F upon A. In this case, the force exerted upon the container would be equal to the weight of the liquid W. So the formula becomes P equals to W upon A. Now we know that the weight W is equal to mass of the liquid M multiplied by the acceleration due to gravity G. Hence, the pressure P becomes P equals to mg upon A. However, the mass M is equal to the volume into density, and hence we get P equals to V rho G upon A, where V is the volume of the liquid. In this case, the volume V is equal to the height of the liquid column H multiplied by the cross-sectional area A. Hence, we arrive at an equation P equals to HA rho G upon A, which is also equal to P equals to H rho G. So this is an equation that we can use to determine the pressure exerted by a liquid. Now let us analyze and interpret the equation P equals to H rho G. In this equation, G is a constant, since G is the acceleration due to gravity. Hence, it is very easy for us to conclude that liquid pressure is directly proportional to the density of the liquid, and that liquid pressure is also directly proportional to the height of the liquid column above a point. In other words, the liquid pressure is directly proportional to the depth of the liquid column. Next, the equation P equals to H rho G does not consist of the area A. So we can also conclude that liquid pressure does not depend on the container's cross-sectional area. And now, the summary of this video. Pressure is defined as force per unit area. Liquids exert pressure in all directions. Liquid pressure can be determined using the equation P equals to H rho G. Liquid pressure increases with depth and density. Liquid pressure does not depend upon the container's cross-sectional area. So that's all in this video. Using the next video, we will solve numerical problems on liquid pressure.